Before the Voyager interstellar mission (VIM) got underway on January 1, 1990, both Voyager spacecraft had been in space for more than 12 years and had returned a large amount of scientific data. Their mission has been extended for an additional 30 years in order to investigate the areas beyond our solar system and look for its heliopause and termination shock. According to NASA, Voyager 1 crossed the line dividing our solar system from interstellar space in 2013. By definition, the term interstellar means between stars. According to physicists, the magnetic field of the Sun and the continuous stream of particles halt where interstellar space begins. Apparently, Voyager 2 entered interstellar space for the first time in 2018. The spaceship is currently more than 17.7 billion kilometers away from the Sun. The two Voyager spacecraft are the only ones that have explored interstellar space yet. The two explorers have looked into the interactions between the interstellar medium and the solar wind, which is the Sun's continuous stream of charged particles. The heliosphere, a sort of shield that encircles our solar system, has also been discussed. Voyager 1 and Voyager 2 are the only two examples of how crucial space probes are to our comprehension of the universe. These probes are providing us with information on the furthest reaches of our solar system in real time, even though we may not have had the opportunity to directly investigate them for many years. NASA engineers are stamping their feet in response to some weird data being sent by the Voyager 1 spacecraft. Consequently, what are the odd communications coming from Voyager 1 coming from the depths of space? Is there any need to worry about or not? You will get to know this and plenty more as we dive into the details of today's show. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. VIM, a new mission. The close flyby of Neptune by Voyager 2 in 1989 marked the end of the Voyager spacecraft's primary mission. The Voyager interstellar mission VIM, which started after the two spacecraft had been in orbit for more than 12 years, is a mission extension. The Heliophysics Senior Review was carried out in 2008 by the NASA Scientific Mission Directorate's Heliophysics Division. The panel concluded that the VIM is a mission that is very vital to continue, and that more DSN Deep Space Network support and funds are necessary for the program. The primary goal of the VIM was to continue exploring the solar system past the outer planets all the way to the heliopause, which is the farthest point in space where solar energy prevails over interstellar winds, and maybe beyond. Voyager 1 and Voyager 2 both passed the heliopause threshold in 2012 and 2018 respectively. Both spacecraft have been able to measure the interstellar fields, particles, and waves that are undisturbed by the solar wind after passing past the heliopause limit. The discovery of an area with magnetic bubbles and the absence of any evidence of the anticipated shift in the solar magnetic field are two notable discoveries to date. In 1998, the whole Voyager 2 scan platform along with all of the platform's instruments was turned off. On Voyager 1, all platform instruments have also been turned off, with the exception of the ultraviolet spectrometer UVS. Despite being set to shut down in late 2000, the Voyager 1 scan platform has been kept operational to look into UV emissions coming from the upwind side. While scans are no longer feasible, UVS data are still being recorded. In 2016 for Voyager 2 and 2017 for Voyager 1, gyro operations came to a stop. 6 times a year, gyro operations are used to rotate the probe 360 degrees in order to determine the spacecraft's magnetic field, which is subsequently subtracted from the magnetometer's science data. Both spacecraft entered the interstellar medium, the flimsy substance that covers the immense space between the stars, during the previous decade, entering a new domain. There, the spacecraft keeps learning new things. Researchers have been taken aback by the interstellar magnetic field's strength and direction, and the new information has even stoked a debate regarding the geometry and activity of the heliosphere, the Sun's magnetic field. Is the heliosphere more spherical than the comet-shaped structure that has long been assumed? And does it change size when sunspot numbers increase and decrease, or is it more stable? Some enticing hints have been provided by the spacecraft. In 1977, Voyager 2 and Voyager 1 both departed from Earth. They weren't the first spacecraft to arrive at the closest of the large planets. Pioneers 10 and 11 held that distinction. The Voyagers, however, were more advanced than the Pioneers and made a number of astounding discoveries. In 1979, Voyager 1 traveled a shorter distance than Voyager 2, arriving at Jupiter earlier, where it discovered that the planet's vibrant moon, Io, had volcanoes. Voyager 1 flew through Saturn in 1980, observing the ring's fine intricacies and finding the first nitrogen atmosphere outside of Earth, around the moon Titan. Voyager 2 traveled a more picturesque course, stopping by Jupiter and Saturn in 1979 and 1981 respectively, before traveling past Uranus and Neptune in 1986 and 1989. The spaceship then began to travel toward other stars. The interstellar medium, as it has been characterized by astronomers, starts where the solar wind, the outflow of charged particles from the sun, terminates. Like a stone impeding water in a stream, this ionized gas or plasma pushes against the cooler, denser galactic plasma flowing around it. Similar to how the top of the Earth's troposphere is referred to as the tropopause, the heliosphere and heliopause refer to the hollow cut out by the sun. According to Don Gurnett, a Voyager researcher at the University of Iowa in Iowa City, we really didn't know how far out the heliopause was at the time Voyager was launched. Some believed that the heliopause might be only 5 times further from the Sun than Earth, or as close as Jupiter, after traveling an immense distance, at 121.6 astronomical units, or almost 4 times Neptune's distance. Voyager 1 passed through the heliopause on August 25, 2012, exactly as predicted by Gurnett 20 years earlier. But the passage was so contentious that NASA didn't make the achievement public for another 13 months. Voyager 1 did, however, detect some signs that it had passed the heliopause. High-energy solar wind particles disappeared, suggesting that the remainder of the solar wind was also left behind. Also, after Voyager's passage, cosmic rays from the outside of the solar system, which the heliosphere partially blocks, became more intense. Yet, many researchers were unconvinced by this evidence alone. There were 2 difficulties. First, Voyager 1's plasma instrument had malfunctioned, rendering it unable to capture the increase in particle density that occurred when the spacecraft left the heliosphere and entered interstellar space. Second, although it was predicted that the magnetic field outside the heliosphere would point in a different direction, it did not. Nature just didn't realize that it was intended to modify the magnetic field direction since it hadn't read the theorist's publications, according to Krimgis. Why the magnetic field outside the heliosphere aligns with that inside is still a mystery. The Sun contributed to the success of Voyager. Voyager 1 was rushing through plasma when solar storms that had earlier erupted in 2012 jolted it, producing electrons there to vibrate and emit radio waves that the spacecraft recorded. These radio waves' frequency demonstrated that Voyager had in fact entered a significantly denser area. A shield of protection, the heliosphere. Researchers must look into this puzzle and offer a solution utilizing data from Voyager and other discoveries. The idea that heliopause fluctuates is not new. Over the past 10 years, researchers have analyzed data from a variety of sources to understand its dynamic nature. This boundary's location and behavior have been better understood thanks to NASA's Interstellar Boundary Explorer (IBEX) spacecraft, which tracks energetic neutral atom emissions. The only spacecraft to leave the heliosphere was Voyager 1 and Voyager 2. Only direct observations at a particular location in space and time were transmitted by the Voyager probe. IBEX completes their statistics by providing more context. Models that predict how their heliopause may alter in the future have been developed by scientists using this knowledge. The heliopause is a border that is continually shifting, in contrast to the solar winds and interstellar medium, which push and pull against one another. Data from more recent heliopause studies, however, contradicts past findings. The IBEX satellite, for instance, found that the brightening of energetic neutral atoms, ENAs, in 2014, which at first suggested asymmetry in the heliopause over a period of months, was incompatible with the models as they are currently. According to data from Voyager 1 and 2 spacecraft, the heliopause appears to have migrated significantly in a short period of time, which may assist to explain the massive time gap between the entry of the 2 probes into interstellar space in 2012 and 2018 respectively. Yet, the heliopause shifts, casting doubt on hypotheses put forth to account for its stability. The study's findings were detailed in a publication that was published on October 10th. These differences in their opinion were intriguing and perhaps even provocative. Scientists expect to learn more about the heliopause using NASA's Interstellar Mapping and Acceleration Probe, a new and improved satellite that will launch in 2025 and be able to detect ENAs. What is causing the heliopause's surprising behavior is still a mystery. In May of this year, the Attitude, Articulation, and Control System, or AACS of Voyager 1, began transmitting garbled data instead of the usual updates on the status and health of the spacecraft. The AACS keeps the high-gain antenna pointed at Earth, indicating that the antenna was still pointed at Earth and not where the AACS said it was, and the ship's radio communications were still steady and strong. Notwithstanding the strange behavior of the AACS Voyager 1 science systems continued to gather and transmit data as usual. Whatever the AACS issue was, it didn't cause it to trigger a fault prevention system that would have put the spacecraft into safe mode in the event of a breakdown. Luckily, NASA experts were able to identify and resolve the problem. The AACS had begun broadcasting its telemetry data using an onboard computer that had long since broken, resulting in the data being jumbled. It was discovered after the command to the AACS was transmitted. After the professionals were able to resolve the issue, he was able to transfer his data home using the appropriate computer. The next challenge will be to determine what caused the AACS to switch systems in the first place. According to NASA, it's possible that another onboard computer gave the system the incorrect instruction. Even though it is believed that Voyager 1's health is not currently in grave danger, the root cause of this issue must be found and fixed in order to prevent further worries. Voyager 1 has been traveling through interstellar space for the past 10 years, leaving behind the Sun's magnetic field, which had previously shielded it from cosmic rays and other forms of interstellar radiation. A touching sayonara. Everything is good after all, right? No matter how well a mission may have gone, there comes a time when difficult choices must be made in order to allow room for further advancement. After 45 long years in outer space, it appears that the Voyagers have reached their destination. It might be time to end the conversation. Due to the current fault and malfunction in its onboard processors, and AACS Voyager 1 will have to be retired. The American Space Agency has begun bidding goodbye to the probe and turning down its equipment. It's incredible that even before the development of modern technology, humanity was able to launch probes into space that survived for such a very long time. The two identical probes that were launched simultaneously and offered us some of the closest images of our solar system's two largest planets have already completed their missions. In 2030, the probes will be taken off their current course. NASA is extremely happy with the performance of both Voyager spacecraft and notes that they have operated 10 times longer than expected. The first Voyager probe still has 4 working parts, whereas the second has 5. The plutonium that powers them on now is degrading, so they won't be able to sustain them for very long. The battery's output is declining by 4 watts annually, which has left NASA with few options. In 2019, NASA scientists shut off the heater for the cosmic ray detector, a crucial part of the probe's operation as they gradually started to degrade its components. With its magnetometer and plasma science instrument likely being the last two, NASA will decommission the probes piece by piece. The extra heat produced by the spacecraft's processors keeps these two warm, whereas the other two are suspended from a 13-meter fiberglass bloom, which will likely take the longest to cool. The Earth is a busy place with signals flying all over the place, making it harder and harder to hear the whispers from the spaceship. In light of the current system bug, the veracity of fuzzy information obtained is further questioned. The two probes' worth cannot be understated, though. These one-of-a-kind perspectives into the vast, largely uncharted space were priceless. It will be another 300 years before humans are able to fully exit the solar system, despite the fact that the astronomers may soon be able to go into interstellar space. What are your thoughts in this momentous finale of an illustrious era? Do let us know your thoughts in the comments section below. If you enjoyed this video, please hit that thumbs up. It will help us to understand our audience and allows YouTube to suggest similar videos to you. Thanks for watching, and we hope to see you at the next one.